Cycle time reduction. I'd like to share with you Stroud's approach to reducing the duration of any repetitive process in a manufacturing operation in order to reduce downtime and increase output. It's applicable to any repetitive activity, such as a planned downtime event like preventative maintenance or a changeover, to unavoidable short stops like a film splice in a packaging process, as well as to manufacturing steps that are within themselves repetitive processes that can be improved upon. We've helped clients apply this approach across hundreds of processes and facilities over the course of 20 years, and they've consistently shown that when applied in the right way, this approach can reduce the duration of any repetitive activity by 25% or more. In this video, I'll share the 5 steps in the approach by telling the story of how an operations team in a beverage plant applied the approach to increase the output of one of their critical production lines. I'll talk a lot about the importance of the mindset with which the approach is applied. And finally, share some guidance on how to get in touch if you have further questions about the approach itself. As I mentioned, we're looking at a beverage production line that was in the position of being production constrained. That is, they could sell more than they could make, which is a great problem to have, but still a problem nonetheless. And what it meant for them was that any increase in production they could achieve from this line would result in additional sales and profits. On this production line, it was the box forming machine that was the bottleneck. It's a pretty standard beverage line. You blend the beverage contents, you pasteurize them, blow mold bottles from preforms, fill those bottles, cap and label them, then pack them into cases and palletize those cases for shipping. And in this case, the filler's production rate was being limited by the effective speed of this box former. This is the part of the case packer that takes flat corrugated boxes and erects them so that containers of product can be placed inside them. And we'll watch a video of it operating in a moment so that you can get a feel for how it works. And it's what we call a pre-PLC machine. So rather than having a speed dial or any kind of programmable controller that would allow you to adjust the speed, its motions are controlled by a series of pneumatic cylinders, air pressures, photo eyes, and other sensors, each of which can be adjusted to influence the cycle of the machine. Now, seeking to improve the cycle of this box former in order to increase its speed was a contentious subject in the facility. So you can see a real quote from one of the mechanics who's concerned about the machine potentially damaging itself at the current rate, let alone at a higher speed. And I share this quote to make 2 points. The first is that this approach works even when there is healthy skepticism about there being opportunity to improve. And second, to reiterate the importance of the mindset you take when applying the approach. It's all about identifying opportunities to improve the cycle and then finding ways to implement them safely and reliably. It is not about sacrificing one priority like asset life in exchange for more production. Now let's follow the team's journey as they work to improve the cycle of the box former using this cycle time reduction approach. Well, let's take a look at the box former in action. I have a short video here that will show its operation. You can see you've got an arm that rotates beginning on the right of screen, and a flat box is raised up into a set of clips in the arm. That arm rotates to the left, opening the box, then lowers it onto a set of paddles. The paddles close the bottom flaps and eject the box into the case packing area. As that happens, the arm raises back up, rotates back to the right to collect another flat box. I'm just going to play the video a couple of times more so that you can get a better sense of these steps. Step 1 in the cycle time reduction process is to define the beginning and end of an individual cycle. In the case of a changeover, for example, the beginning might be when the line goes down at the end of one production run, and the end might be when the line starts back up again on the new product following the changeover. In this case, the team defined the start of the cycle as being the moment the arm, with a flat box just inserted into its clips, begins its rotation to the left in order to open the box. They define the end of the cycle as the moment when the arm is in the same position once again, about to open a new box. When the cycle you're studying has an ongoing repetitive nature, like the Boxformer, it's important to make sure you've captured the complete cycle. Step 2 in the process is to list out all of the steps you can see within the cycle. In this case, the operations team made a video of the Boxformer's operation, which we just saw, and then studied this video to identify the series of steps the arm makes as it collects, opens, and places each box. A quick note, this example I'm sharing focuses on the cycle of this box opening arm. You could also apply the approach to the portion of the machine that folds the bottom flaps and ejects the form box. In this case, it's the arm that's controlling the cycle time of the whole machine, but that isn't always the case. You can see on the slide here a template the team used to move through the process, and the highlighted area is where you list the steps you've just identified. The critical thing here is to identify every single step that represents a part of the cycle so that nothing is missed. In this case, each time the Boxformer initiated some new movement, it was taken to be a new step in the cycle. For example, rotating left to open a box is considered an individual step. You can see the steps the team has identified and laid out here. First, the arm opens with a box inside it, from the right of screen to the left, opening the box. Then the arm lowers the open box down onto the paddles that close the bottom flaps. Then those flaps are closed. The next step, the arm raises back up with no box. Then it rotates from the left of the screen to the right. Then there's a brief pause. Then the next flat box is pushed up into the arm's clips, and then the arm opens that box, beginning the next cycle. The other thing the team did was to identify the frame in the video when each step began and finished. You can see those numbers listed next to each step. The team did this by making a video, which we just saw, using a standard cell phone camera, which operates at 60 frames per second. So each frame represents 1/60th of a second. Most phone camera apps also allow you to scroll through the footage frame by frame, which is what the team did here to identify the frame numbers. You can see that one complete cycle from the moment the arm begins opening one box to the moment it begins opening the next takes 73 frames or 1.22 seconds. This brings us to the next step in the approach, which is to take the duration and timing of each step and plot them visually as a Gantt chart, which you can see here. The area inside the orange highlighted box represents one complete cycle. Another thing you may notice is that all of the steps appear to be in series. That is, each step only begins once the step before it has finished. This is going to become particularly relevant as we move on to step 4. In step 4, we take what we've learned about the steps in the cycle and determine what opportunities may exist to reduce the impact of each step on the cycle's duration. We do this by taking each of the steps in the cycle and subjecting it to 4 questions. The first one of these is, what would it take to eliminate this step? As in, how could we adjust the cycle somehow so that it still achieves the desired outcome without this step being performed at all? A classic example of this type of opportunity from the world of motor racing pit stops is the change from 5 small wheel nuts on a wheel to 1 big one. It takes no more time to unscrew a large wheel nut than it did to unscrew a small one, and the steps of unscrewing the other 4 are eliminated. If there's no way to eliminate the step, we move on to the second question, which is, what would it take to do it outside the cycle? In the case of the Boxformer, where the cycles are really back-to-back, there isn't any outside the cycle time to move a step to, but in the case of a changeover or a film splice, for example, there are often steps in the process that can be performed before the line goes down or after it has come back up again, reducing the time the machine is down for. The third question is, what would it take to begin the step sooner, potentially in parallel with the step before it? Here, challenging the idea that a step is dependent on all prior steps being finished before it can begin. This is not always required, as you'll soon see for our Boxformer. Finally, if there don't seem to be any feasible opportunities to eliminate, externalize, or advance the step, you move on to the fourth question. What would it take to reduce the step's duration? When I mentioned earlier that seeking to reduce the duration of a process cycle could be contentious, it's usually because of this question. One can presume that you're trying to make parts of the process go faster than they were intended to, creating risk. Of course, this is always a possibility, but each opportunity to reduce the duration of a step must be evaluated on its own merits. And there will always be opportunities to reduce step duration in this way. Some opportunities will be more complex to realize than others, and they may be foregone as a result, but they are still opportunities nonetheless. Also, as you've seen, there are 3 other potential ways to reduce the impact of a process step on the overall cycle duration before needing to consider reducing the step duration itself. One other point to emphasize here is the way you ask these 4 questions. They deliberately begin with the words, "What would it take?" to get the group in a creative mindset in order to develop new possibilities. Sometimes there's a tendency to want to fly through the process, and you hear questions beginning with the words, "Can we? Can we eliminate this step? Can we do it outside the cycle?" etc. This framing puts the group in a critical mindset, where to say, yes, there is a way to do that can imply that we've done a bad job in the past because we haven't thought of this before. Always begin questions with, "What would it take?" And don't let the group or yourself off the hook until you come up with something. The idea is to list as many opportunities as you can come up with so that when it comes time to choose some to implement, you have a long list to work with. Now, returning to our Boxformer, the operations team identified several opportunities that they deemed were valuable in shortening the cycle and could be implemented quickly and safely. The first is this opportunity here, which was to eliminate the pause that occurs between when the arm rotates back to its closed position and when the next flat box is pushed up into the clips. The next opportunity they identified was this one here, which was that the step of the arm lowering could actually be started earlier. So rather than waiting until the arm had opened all the way up before beginning to lower it down, they advanced the lowering of that arm so that the arm opened and lowered at the same time. Now the other side of the coin with that opportunity is this check mark here, which is where the team also realized that it was possible to advance the closing of the arm. It didn't need to wait until the raising of the arm was complete. It could begin closing partway through the step where the arm raises back up again. And then finally, the last opportunity, which is represented by these 2 check marks, is the team realized they could also advance the point in the cycle at which the arm opened. They didn't need to actually wait until the new box had been pushed all the way into the clips. They could start opening the arm sooner as well. With these changes implemented, here's a revised Gantt chart in yellow of what the team expected to see. First, you can see that this pause, which was in the original Gantt chart, has been removed from the improved cycle. Next here, you can see the arm is opening and lowering in parallel rather than waiting for the opening to finish before the lowering begins. And then same again in reverse, the arm is rising and closing in parallel. And finally, this small opportunity to begin opening the arm before the box is pushed all the way up into the clips. With all of those changes implemented, the team anticipated the duration of the cycle would fall from 73 frames or 1.22 seconds to only 53 frames or 0.88 seconds. This represents a 27% reduction in the duration of the cycle. Put another way, this would produce a 38% increase in the production rate of the Boxformer. We should also note that the changes made all stemmed from questions 1 and 3 of the 4 cycle time reduction questions. They included eliminating a pause and advancing 3 steps in the cycle to begin in parallel with the step previous. So none of the opportunities came from making any of the mechanical components move any faster than they were moving before, which alleviated the concerns of the mechanic that we discussed earlier. It also means that the wear rate of any of the parts on a per box formed basis will be exactly the same as it was before. So there is no additional risk to asset life being incurred because of these changes. So how did it all turn out? The team made the series of adjustments they needed to achieve their desired changes to the cycle, and the machine ran perfectly, now at the reduced cycle time they had predicted. This outcome more than satisfied the rate increase they needed to unconstrain the filler and increase their output. Let's watch it run a couple of times. So even with the naked eye, you can start to see some of the changes that they made, like the arm opening and lowering at the same time, as well as rising and closing at the same time. To review the 5 steps we've discussed, they are: define the start and end of the cycle, list out the steps of the cycle, time each step and create a Gantt chart as a visual representation, take each step one at a time and ask before cycle time reduction questions. Remember, frame those questions as what would it take, not can we? And finally, verify the results when you implement the changes. And keep in mind that you may not elect to implement all the ideas you come up with to reduce cycle time, and you may not generate all the potential ideas the very first time you apply this approach. There's always an opportunity to repeat the process and deliver further improvements to cycle duration. And as we've discussed, the approach can be used on a manufacturing step that is itself a repeating cycle, just like the Boxformer, but it can also be used on other repetitive processes such as changeovers, preventative maintenance, film splices, and other unavoidable short stops. I hope you've enjoyed the video and gotten something new out of it. If you have further questions about how to apply cycle time reduction successfully in your manufacturing operation, please reach out and we'll make time to speak with you. You can schedule a brief phone call with one of our practitioners using the scheduling link below, or you can write to us at ctr@stroudinternational.com.